This video shows how to test the normality assumption as a requirement for the one-way ANOVA in SPSS. First question, what has to be approximately normally distributed? It is not the dependent variable, but rather the residuals of the ANOVA that should be normally distributed. Simply put, residuals are the difference between values predicted by the model and observed values for the dependent variable. There are three possible ways to check for normality. First, an analytical test, like the Shapiro-Wilk-test. Second, a histogram. Or third, a QQ plot. The Shapiro-Wilk-test is oversensitive to unimportant deviations from normal distribution in large samples. This is a phenomenon for all analytical tests, for which you can find a source in the video description. A QQ plot is the easiest to interpret, therefore we continue creating one for the residuals of the ANOVA. To acquire the residuals, we can calculate the ANOVA and save them. For this, go through Analyze, General Linear Model, Univariate. Put the dependent variable in the corresponding box and your group variable in the fixed factors box. Furthermore, go to Save and select Standardized Residuals. Nothing else is needed and you can proceed by clicking OK. The output created following this can be ignored. We can now plot a QQ plot by going through Analyze, Descriptive Statistics and Explore. Put the residuals that are now at the end of your variable list into the dependent list box. Then click on the Plot button and uncheck Stem and Leaf and check Normality Plots with Tests. Under Display Options, you can select Plots and click OK. The resulting output will show you, among other plots, the desired QQ plot. The interpretation of the QQ plot is straightforward. The dots represent the residuals and the line the perfect normal distribution. Therefore, the distances between the dots and the line should be minimized. Again, there will be acceptable deviations, especially on the edges of the distribution, meaning the upper right hand and the lower left hand corners. For my residuals, deviations in the top right hand corner can be a bit problematic. If you are in doubt, you might consider going with the Kruskal-Wallis test, which is the non-parametric alternative to the one-way ANOVA, and for which I have linked a playlist to go from A to Z. If you find your residuals to be approximately normally distributed, you can continue with your one-way ANOVA, which is shown in the following video.